A red giant is a type of star in the later stages of its evolution characterized by its large size and relatively cool surface temperature compared to the earlier stages of its life. Red giants are typically more massive than our Sun and represent a transitional phase in the life cycle of certain stars. Here's a brief overview of how a star evolves into a red giant. Formation. Stars begin their lives as clouds of gas and dust called nebulae. Gravity causes these nebulae to collapse and form protostars. As the protostar continues to contract, its core temperature rises. Main sequence. The star enters the main sequence phase, where it fuses hydrogen into helium in its core. This phase can last for millions to billions of years, depending on the star's mass. Depletion of hydrogen. In the core of the star, hydrogen fusion proceeds, releasing energy that counteracts the force of gravity trying to collapse the star. However, the star eventually exhausts its core hydrogen fuel. Helium fusion in shell. As the core runs out of hydrogen, the star expands, and the outer layers become cooler. Helium fusion begins in a shell surrounding the core. The increased energy production in the shell causes the outer envelope of the star to expand. Red giant phase. The star enters the red giant phase as it expands and its surface temperature decreases. Although the core temperature increases due to helium fusion, the outer layers of the star become cooler, causing the star to take on a reddish hue. Red giants can be significantly larger than their original size during the main sequence. Helium burning. Eventually, the helium in the core becomes the primary fuel source, and the star undergoes helium fusion, forming heavier elements like carbon and oxygen. This process further contributes to the expansion of the outer layers. Planetary nebula. In the later stages of a red giant's life, it may expel its outer layers into space, creating a shell of ionized gas known as a planetary nebula. The remaining core, which is composed mostly of carbon and oxygen, is exposed. White dwarf. The core that remains after the expulsion of outer layers becomes a white dwarf. White dwarfs are dense, Earth-sized remnants of red giants that gradually cool over time. It's important to note that the fate of a star depends on its initial mass. Low to medium mass stars like our Sun will eventually become red giants, while more massive stars may undergo different evolutionary paths, leading to outcomes such as supernovae, neutron stars, or black holes. The evolution of stars is a fascinating process that shapes the composition of the universe.